So very good afternoon to all of you. So we are going to start our new topic that is about the data preparation is in data sciences. So before using any machine learning model upon certain data, we need to prepare a data set. We need to prepare a data in such a way that it should be there should be total clarity in the data. The data should be cleaned. The data should be well maintained, and the data should be well organized. And if we have certain problems in the data set, we need to clear these problems. We need to remove these uh, impurity within the data. That is actually the data preparation tells us about. So whenever we are creating data sets, whenever we are creating certain data sets, there is some kind of ambiguity we are having in certain data sets. We are having some impurity within the data sets, and we need to remove this impurity within the data sets so that we can forward this data, so that we can put this data for a desired machine learning model in order to we can make some predictions, or we can do some classification problems. But this data preparation is one of the crucial, one of the important topic in data sciences, because we need to deliver the data. We need to deliver the data in such a way that this data should be completely cleaned. It should be completely pure, so that our machine learning model, whenever it tries to predict something, whenever it tries to classify the things, it should give us a very high result. It should give us a very accurate result. But this result, this classification result, these classification matrices that our machine learning model is giving, it is giving us on the basis of the data. So the data should be prepared. Now, coming to the point, coming to the next slide, that is, we are going to start this data preparation. Before analyzing data, if you are analyzing the data, if you are visualizing the data, a data scientist must extract the data and make it clean and valuable. What it means is that we need first to read the data set. If you want to work on a certain data set, you need to read the data. You need to extract the data from your local disk or wherever it is, and we need to make it clean. We need to make it valuable in terms of that there should be no ambiguity in the data. Now, before data can be analyzed, we need to import it. We need to extract it so that we can work on it. Now, I'm taking one of the example. I'm taking one of the example of the health data. We have the health data set. I have already downloaded it, and it is present in my local disk. And I want to read this health data I want to read this health data from my local disk, and so that I will work on this health data. Now, see, I have just used the pandas, because pandas is used to deal with the data sets. So I will use the panda library. That is one of the one of the good library, one of the important library in the Python that we are using in order to, so we can read certain data sets. We have certain formats of data sets, but in this example, I have one example that is of the CSV, that is comma separated value file, that is comma separated value data sets. So I am just reading the data set, and I just put here import pandas as PD. This means I am importing a library pandas with the name PD. So I just put in the one other name here, hello data. This is the name of the data frame. This is the name of the name of the panda object that I am putting here. This is I have put here that hello data. It is not necessary that I need to put the hello data. It is not necessary to I need to put the hello data. I can put anything, any name here. It is not mandatory that I need to put the health data, because I put the name health data here because the data is regarding the health. The data is regarding the health. That is why I put here the health data name as a health data. And after that, I am using one of the function that is available in our pandas, that is read underscore CSV. So this function enables us to read or extract the data which is present in our local disk. So data.csv, this is one of the file. It is one of the file in my local disk, where actually I'm reading this. I'm reading this data file. Now I used certain statements there in order to I will extract the data. I used The name of the data frame I already discussed with you. I used the header, which means that whatever the variable name should be there, it should be in the first row. It should be found in the first row. By default, whenever we are using the Python language, by default, our row name starts from the zero. From indexing starts from the zeroth row. And I told you earlier that this is a comma separated file, and I have written there one argument, that is SEP equals to within the underscore I put here the comma, that every value in the file will be separated with the comma, will be separated with a comma, that is known as comma separated file. So now I read it, the data set, I extracted the data from my local disk. Now I need to do the data cleaning. I need to do the data cleaning. I have some problems with my data set. There are certain ambiguities. There are certain values that are not that are not good. That is totally dirty. That is totally uncleaned, and I need to clean these data values so that I can work with the data set properly. Now look, if we look towards the data set, there are certain values. These values are known as dirty values. The dirty values, or wrongly or unregistered values are there. If you look towards the PPT, there are none values. Certain rows are there, and why there is some none values are there, NaN, that means not any number. And we have one more problem there. If you find out the third column, that is maximum polish, and within this maximum polish, I am having the in the eighth position row, I am having one value, that is AF, and it can't happen that any maximum polish could be AF. It doesn't mean anything here. It doesn't mean anything here. So this is a kind of ambiguity within the data. One more thing, if you see the 11th positional row, and in the average polish, I have one more value, that is 9,000. But before for this 9,000, I have a space between a 9 and 0. I have a space between a 9 and 0, and it can't consider it is a numeric value. It will consider it as a non-numeric value. So this is one more problem. So I have certain problems there. None values are there. So I can't define any value for these non values. I have the AF within a maximum polish. I have in the average polish maximum, I have 9,000. That is not possible. I have the 9,000, but for this 9,000, I have a space. I have a space between a 9 and a 0. It will not consider it as a numeric value. So I need to remove these ambiguities. I need to remove this dirtiness within my data set, so that I can give this, I can forward this data to my machine learning model, and based upon this data, it will make some predictions there, it will make some classification there. But the problem here is that we need to clean the data. We need to clean the data properly. So for that purpose, I will do now one thing, that is whenever I will clean, I already discussed these problems with you, that AF is there between the 9,000, there is a space, it will not consider it as a non-numeric value, and average polish of 9,000 is not possible. If we see the normal man, 9,000 average polish is not possible, and there are some blank fields, that is none fields are there. I need to remove these fields so that I can work with the data set properly. Now see, I will remove these blank rows. Why there are none values, I will remove these blank rows. We see that non-numeric values are there. That is 9,000. Between the 9,000, there is a space between 9 and the first 0. And AF, these are non-numeric values, are in the same row. They are in the same rows where we have the missing values. You can see this 9,000 is there, but in the fourth column we have the none. In the fifth column there we have the none. And for the same AF, in the eighth positional row, we have before AF there is a none, and after AF there is a none. In the preceding column and in the successor column, we have the none values. So we will try to do one thing. We will try to remove these blank rows, and in this blank rows, this 9,000 is coming, and this AF is also coming. So these non-numeric values will also be removed from the data set, because we need to remove these non-values. I will remove only those rows where I will find out this none value. Now see here. So for this purpose, I will use a particular function that is drop any. This function is actually this is present in the pandas. We can use this function. We can use this function in order to I will drop some rows here. I will drop some rows here. Now see. Now see, after using the drop NA, after using the drop NA, I can remove this. I can remove after using the drop NA. I can remove those rows where I am finding out the none values, where I am finding out this 9,000 AF. Now I am passing within the drop NA function. I am passing axis is equal to 0. That means we want to remove all those rows where I am finding the none value. This axis is equal to 0 means I am actually doing an operation with the rows. If I will write there axis is equal to 1, that means I am actually making some operations in columns. But this time I am just putting here axis is equal to 0. That means I am making some operations in the rows. Now see, this is the result. This is the resultant data set. After making this operation, after performing this drop any operation, I am having this data set now. Now see, you can find out some rows are missing now. Some rows are missing. You can find out the 5th positional row is not there. The 11th positional row is not there. The 8th positional row is not there because I used the drop any function. I was having some none value there. I was having some ambiguous value there. So I try to remove these values. I try to use the drop NA function in order to I will remove these all the values. Now I can say, now you can see the difference between this data set and the data set I was having actually. Now I am not seeing any ambiguity there. I'm not seeing any dirty data there. Now the data is totally pure. Now the data is totally pure. So I can give this data now to a machine learning model and I can train my machine learning model based upon this data. Now I can say this data is totally pure and I can use this data for my machine learning model. This is how to prepare a data. This is how to clean a data in a proper way. This is how we can remove the ambiguity. We can remove the dirtiness in my data set. We have certain functions we can use for columns also, but as of now I use this thing for rows only. But this time the example I have taken already, there was some ambiguity, there was some dirtiness within the data, and I try to remove all this dirtiness, all this ambiguity, and I try to make this data set very comfortable for my machine learning model. So this was about how to prepare a data in a well-organized way. Thank you all of you.